Hi friends, welcome to Engineering Clinic. Today we are going to see manet routing protocol. We have one examples folder. So in the SRC, see we have an examples. In NS3.38, we have an example folder, CD examples. The first examples you can solve is here only. You can see channel models, energy, error model, IP version 6, naming, routing, socket, traffic control, tutorial, wireless, and UDP client. So these are the different things available in. Yes. So first let me go into routing. Okay. So CD routing. Okay. Now the routing, I have one example. There are so many examples there. Here I have something called as manet-routing-compare.cc. I have one source code called as manet-routing-compare.cc. Okay. So this source code I will be doing it here. Now PWD. I use which folder. Okay. Now I'll do everything here. Okay. Now we are going to see one example called as manet routing compare.cc file, which is located in the following directory. So this is the following directory where it is located. Okay. Move this file to ns all-in-one hyphen 3.38 slash ns hyphen 3.38 slash scratch folder for execution. Okay. So move this file or copy this file. So I can say copy this file. Copy this file to ns all-in-one ns3.38 slash ns3.38 scratch folder. So all the files, if you want to run it, they have to come to the scratch folder. Scratch folder has extra permissions and extra modules, extra linkages to run the ns3.cc files or .python files. It has to move to the scratch folder. Okay. So all .cc files for execution have to be moved to scratch folder. Okay. So this is where we are going to move everything to the scratch folder. Okay. So now let FTB day one. Okay. So now this is where I am going to move. So I can either use GUI to move or through command I can do. So for your understanding, I will go in the GUI mode. So now I have the file ns all-in-one 3.38, ns 3.38, then examples, the folder examples, routing, and we have one file called as manet routing compare. So here this is the file. Right click, copy. You can see I'm just copying it here. Copy. Right click, copy, and go to ns 3.38 and scratch folder. Paste it here. Paste. So now this manet routing compare.cc, I just pasted out here. Now this is what I am going to see for the next 1 hour. Okay. Actually, this is one project. This is one project, and most of the students across the world they do for comparing 4 protocols. Okay. So what are the 4 protocols is? Okay. So this manet routing compare is a comparison project for comparing 4 protocols, wireless protocols, namely AODV, TSDV, DSR, and OLSR. So these are the 4 things they are going to compare. Okay. So in many in the world there are many people they use this project. Okay, AODV, DSDV, DSR, and OLSR. Okay. Now what I'm going to do is in the next 1 hour I'll be completing this project. Okay. So assuming that I know NS3, I know how to read a code, then I want to do this project. Just in 1 hour I can able to complete this project. Okay, this is what I'm going to explain you. So I already have a video also on this. I'll share the video link also. Even this video link also I'll be sharing it for the end of the day, so that today evening if you have a time you can go through this. Okay. So this way I'm just going to it now. Okay, now I'm just opening this file. opening this file now for explanation. Okay. So now here, now I am in this folder NS3.38, gedit, scratch, manet-routing-compare.cc. Now this is the file I am just opening. Now opened here. Now this is what the file what I have. Okay. So you can see the total number of lines in this file is almost around 428 lines. The total number of lines in this file. Okay. Anyway, I'll just explain you everything is how it works. Before that, you can see in the top they have given some explanations here about this example. You can see here. This example program allows one to run NS3, DSDV, AODV or OLSR under a typical random waypoint mobility model. So we are using a random waypoint mobility model and for these three protocols DSDV. By default, the simulation runs for 200 simulated seconds, of which the first 50 are used for startup time. The number of nodes is 50. Nodes move according to a random waypoint mobility model with a speed of 20 meters per second and no pass time within a 300 cross 1500 meter region. The Wi-Fi is ad hoc mode with 2 Mbps rate using 802.11b and a Frisch loss model, Frisch propagation loss model. The transmit power is set as decibel dBm. Okay, 7.5 dBm. Decibel milliseconds. It is possible to change the mobility and density of the network by directly modifying the speed and number of nodes. You can change the speed and number of nodes. It is also possible to change the characteristics of the network by changing the transmit power. As the power increases, the impact of mobility decreases and the effective density increases. So you can able to alter the transmit power also. The transmit power is 7.5 dBm. You can change it to 10 dBm also and just see how the performance varies. By default, OLSR is used. By specifying a value of 2 for the protocol will cause AODV. Specifying a value of 3 will cause DSDV. Okay, so we can use OLSR, AODV and DSDV for all our work. By default, there are 10 source sync data pairs sending UDP data at an application rate of 2 MB per second. That is 2 kilobits per second each. This is typically done at a rate of 464 byte packet. That means 4 number of 64 byte packets per second. Application data is started at random time between 50 to 51 seconds and continues to the end of simulation. So total number of simulation is 200 seconds. You can see 200 seconds. Among that, first 50 is startup time and after 51, it continues to the end of the simulation. Okay. So the program outputs a few items. Packet receptions are notified to STD out and this is what. Okay. Now this is what the explanation of the source code. But anyway, I'll just go and then tell you the source code of how this is been written. Okay. So first thing is we have some header files which is included here. The header files are AODV module, applications module, core module, DSDV, DSR, internet module, mobility module, network module, OLSR module, and YAN's Wi-Fi helper. So we have a Wi-Fi also. So that's why we have a Wi-Fi helper. And F stream for file stream, IO stream for input output stream. Okay. Because we want to write something to the file output and we want to read from the streams also. That's why we use the F stream and IO stream. So these are all C++ objects. But please understand, again, I'm just telling for you need to understand this. You don't need any source code to be written over there. Okay. So you need not write a source code right from the beginning. Already source codes are there. Only thing is you need to understand what is the code is all about. So once you understand it, then you can modify. Simple things you can modify. Even if you want to modify, upgrade something, you can able to do that once you start doing the codings. Okay. So now I have two thing namespace NS3 and DSR. So DSR have a special meaning. That's why we use a namespace. So namespace means something like this. For example, using anyway, I just write down in this here. Using namespace, if I use VIT Chennai, okay, if I use like this, then whenever I say VIT Chennai dot FDP dot wireless dot So let me take some name here. Someone is, let's say, first thing is Dr. Siva Balan. Okay, dot Siva Balan. Sorry. Okay, suppose if it is like this, every time whenever I want to use, I will be using like this. Okay, namespace. Instead, what I do is directly I can able to use. If a namespace is there, I need not tell every time VIT Chennai. Just only this thing. Okay, ftb.wireless.sivabalan means this ftb.wireless.sivabalan belongs to VIT Chennai. Okay, so this how the way I can able to refer every time. So this is the purpose of having a namespace. Okay, so again one more example is, so I am Pradeep Kumar. So if I use VIT Chennai, if I don't use this, so let's say if I don't use this, then VIT Chennai dot Pradeep Kumar, VIT Chennai dot Vetri. Like that we have to write. So if I use namespace here and simply use Pradeep Kumar means Pradeep Kumar belongs to VIT Chennai. Vetri will belongs to VIT Chennai. So this is the why we write the namespace here. Okay. So NS3 means all the classes which you use in the source code will have a tag of NS3. But every time we need not write NS3. So to avoid that, we use it. Else, we have to use like this NS3 colon double colon. Let's say Yans Wi-Fi helper. Like this, we have to write every time. If NS3, if a namespace declared, simply write Yans Wi-Fi helper phy equal to new Yans Wi-Fi helper. Like this. If NS3 is not there, then what you have to do is we have to use NS3 colon then NS3 double colon. This is how the way we have to write the source code. So to avoid that, we use the namespace. Okay. So now the purpose of namespace, you might be knowing why we write the namespace here. So the namespace here is NS3 and DSR. Okay, there are two namespace. Okay. Now log component means when I want to do the logging, log means when I want to, when it set the log files, then I need to know what is the name of the log file. It is manet-routing-compare. So I'm just going for manet is mobile ad hoc networks routing comparison. That's what I'm just doing. Okay, now class routing experiment. First thing is I have a class. So this is a C++ class and public routing experiment. This is called the constructor. Constructor. See, one source code I'll just explain you completely. And in 6G also I'll explain, and in flying networks also I'll explain the source code completely so that you will understand, okay, this is the source code analysis, and after you can go inside for simulation. Okay, right. Now routing experiment is a constructor. So constructor and the class name will be having the same name. As we have studied in object orientation, the constructor and the class name will be holding the same name. Okay. Just now void run. So we have a run function that uses number of sinks, transmission power, and CSV file name. CSV file name for sending the data to my CSV files. Okay. So I'm having command setup, integer argument count and character argument vector. So this again argument count and vector is very important in general in C programming. It is very important. Maybe just to show you one small coding. Hash include std lib at h, then hash include stdio.h, then integer main int argument count character star argv. Sorry that I'm just writing a faster program. So I'll just name this file as file.c. I'm just naming it as file.c. And what I do here is integer a equal to a to I of argv of argv of 1, int b equal to a to I argv of 2. Okay. Int c equal to a plus b. Printf c is percentage d. So comma c. Okay, I'm just using this. So this is my coding. So what I did here is argument count and argument vector. See that I have not sent any value for A, B. So, but I am going to read the value from argument count of 1. I want to send it one value. Argument vector of 2. I want to send another value. The whatever value I am sending is character array, means it is a string. But I want to convert the string into integer. Further, I use a function called as a to I. A means string, I means integer. So I want to convert into string into integer. That is allocated to A and that is allocated to B, two variables. Now C equal to A plus B. Whatever A and B holds, I am just sending to C and I'm printing the value of C. Now this is my program. Okay. Now once you understand this concept well, then NS3 or NS2 or any discrete programming you can easily understand. Okay. So now I'll just come back here, open a new terminal. You can see I have a file.c. This is a file.c. Compile it, gcc file.c. Okay, no errors. You can see one file called as a.out got created. So this is output file which got created. Now /a.out. As I told you already, any file if you want to run from the current folder, you have to use a /a.out 6,8. I am just using two numbers 6,8. Now you can see C is 14. You can see 6 plus 8 is 14. Now when I want to say 6 plus 10, C is 16. Now 699. Now this is 17998. So what I am doing here is I am using a argument count and argument vector. Instead of changing this value every time, I just send the value through command line arguments. So this we called as the command line arguments. Okay, I am just sending the value. Else what you do is every time you change the value and then recompile the program. So you need to recompile every time the program, the values are being changed. But here, no need of recompilation, just change the value here. No, but if you give empty value, it will share that a segmentation fault. But you need to give like this. Now 0.1 comma 0.2. If you say that, it will give 0 because it is only integer. I convert everything to integer, not into float. So it know only about the numbers. So let me use 100.96, 200.7. The value is 300. 100 plus 200 will be 300. Now this is we call as a command line arguments. Okay. So this program, this is what we have. Argument count and argument vector is used here. Okay. So this is the argument count and argument vector. So double star means it is a string character array. Okay. Now I have a packet receiving function. Receive packet. The parameters are the socket as a parameter. Here the address IP version 4 address is a parameter and then number of node. This is the set of packet receive. And check throughput. Now I want to compute the throughput of my packets. I want to have a function for checking the throughput. Then port number. So port number I want to use unsigned integer 32 bits. Then total bytes I want to calculate received bytes and total packets received. Then I want to use a CSV file name. For that I create one string file name. Number of strings I want to use the number of string nodes. Then the protocol name. So here the protocol name I want to use is AODV, OLSR, DSDV and DSR. These are the protocols I want to use it here. Okay. Then double MTXP means transmission power. Here it is 7.5 dBm. 7.5 dBm. Then trace mobility. You want to say no, the nodes are moving here and there. You want to trace the how they are moving. In that case, it's a Boolean variable. The name of the protocol that I want to select number 1, 2, 3, 4 like that. Okay. Now routing experiment. I am just creating one constructor. Port number by default is port number 9. The total number of bytes to be initiated is 0. Received packet is 0. The name of the CSV file is manet-routing-output.csv. Now what I do is I'll just change it to VIT Chennai.csv. Now, okay, I'm just doing this VIT Chennai.csv. Then trace mobility false. I'm not going to trace the mobility. I make it as false. Initializing. Protocol number 2 is AODV. Okay, now what they have given here is, you can see here in the text here, OLSR is default, 2 for AODV, 3 for DSDV, and 1 for, I think, OLSR, I think. Let's see. We'll see what is that. So, but 2 means AODV. Okay. So now the print received packet. Whenever I want to receive one packet from, so received one packet from address, which node, who is sending the address, who is the sender address, and from where we are receiving. So this is the first one, receiving the packet from who, print received packet. So this code is about printing the received packet. Next thing is, every time a received packet is received from the socket, it upgrades bytes total equal to packet of get size, and packet received equal to plus equal to this thing. So what does it mean is equal to packet received plus 1. This is what it means. So packet received, whenever a packet is received, it will be upgraded with one packet. Okay, one packet, second packet, third packet, like that, plus 1 will be upgraded here. So this is what the packet received logic means. Okay. So now routing experiment. So we have check throughput. So the throughput is computed like this. Okay, total kilobits per second is bytes, total bytes received into 8, that is converting bytes into bits, 8 divided by 1000. Because in bits per second now, it is milliseconds, I am going to convert into seconds. Then that will be printed to the CSV file name. So in the CSV file name, that will be printed there. And that will be running for the check throughput. So this experimentation is, routing experiment is for checking the throughput. We are plotting the throughput values. Next thing is set up packet receive. So what kind of packet I am going to use? I am going to use UDP socket factory. So you know we have two kinds of packets. One is UDP, another is TCP in the transport layer. I am going to use UDP, means no acknowledgement, simple to implement. That's what I am going to use it here. Okay. Now here we have command setup. Now I said that CSV file name, trace mobility, and protocols. Protocol you can see 1 means OLSR, 2 means AODV, 3 means DSDV, 4 means DSR. So this number you need to keep it ready. And every time when the CSV file name, we can convert the CSV file name. So this name also you can see, trace mobility and protocol. So we are going to use these two, CSV file name and protocol. We will be using it. I'll show you how that can be done. Now we use a CSV file name here, and this will be sent to this simulation second, receive rate, packet received, number of things, routing protocol name, and transmission power. All these 4 parameters will be sent. Number of things is 10 and transmission power is 7.5 dBm. That will be sent across. Okay. So the total number of Wi-Fi nodes is 50. So total number of Wi-Fi node I want to use is 50 nodes. If you want, you can use 100, 200 like that. Okay. So 50 nodes, 50 nodes or 100 nodes or 150 nodes like that. If you want, you can able to increase the number of nodes according to your comparison. So total simulation time is 200 seconds. So 200 is, if you think 200 is vast time, you can reduce that also. But let's see how the 200 thing works. The rate at which it does is 2048 BPS. So this means 2.048 kbps, kilobits per second. This is what it means. Okay. So the physical layer mode is, I am using a DSSS radio model with a 11 Mbps. So this is nothing but 802.11b. And the name of the trace file is manet-routing-compare. This is the name of the trace file. This also I will convert into VIT Chennai. Okay. And node speed is 20 meters per second. Okay. So if you want to say 10 meters per second, how the parameter changes. If you want 20 meters per second, how it changes. If you want to use 30 meters per second, how it changes. You can vary that. Okay. So let me use 20. There is no pass time in the nodes. So let it be 0. The protocol name, variable name is protocol. Okay. Now we have the on-off application of packet size and data rate. So either full packet data rate or no packet data rate. So packet size is full or 64 or 0. So if 64 is there, the full packet size, 0 means no packets. Similarly, data rate is 2.048. This is the rate 2.048. If it is on-off application, means either full or no data rate. That's what on-off application, either 0 or 1. 0 means 0, 1 means 2048 BPS. Here packet size 0 means 0, 1 means 64. Okay. Then Wi-Fi remote station manager. So we just create one Wi-Fi because all the nodes are going to use Wi-Fi only. So for that we use a remote station manager like a access point. So we create the number of node. Now you can see the first thing, node container. Now recall our first class abstraction is node in NS3. First abstraction we use node container. Okay, first abstraction we are using. Ad hoc nodes, the name of the variable is ad hoc nodes. Create totally 50 nodes. So we are creating 50 nodes here. 50 nodes. Because already n Wi-Fi we have created 50 here. So these are 50 nodes that we are creating here. Okay. Now standard is Wi-Fi standard 8.2.11b. We create one Wi-Fi helper classes. Okay, these are Wi-Fi helper classes. So we call this as topology helper classes. We have seen. Okay. Then we have a physical layer and we have a channel here. Channel. So there's like a channel in NS3. So the node we have used and we have used the channel also in NS3. So node in NS3 and channel in NS3. And propagation delay is constant speed propagation delay model. That means what? Whenever you move in a constant speed, there will be a delay in the propagation. So that's what constant speed propagation delay model. And propagation loss model is frisk propagation loss model. So we just go for a frisk and create a channel path. So create a communication path with these available parameters. What are the parameters? My standard is 802.11b. I have a physical layer. I have a Wi-Fi channel established with a delay and a loss model. So using that, you create a channel. Okay. Then after the physical layer is done, we have to have a MAC layer. So medium access control. So on what speed the data rate. So here the constant rate Wi-Fi manager. That means all people in the room will have a same Wi-Fi speed. That means constant rate Wi-Fi manager. So under that we have two modes. One is data mode, another is control mode. And transmission power starting here is 7.5, ending also 7.5. So we have starting and ending 7.5 dBm. So that means no loss in the decibels. Okay, 7.5 dBm. So on both the cases. Then for type ad hoc devices, it's ad hoc Wi-Fi. Ad hoc means there is no access point, but everything is based on ad hoc. All the nodes can talk to each other. So all Wi-Fi nodes talks to each other. So this is what ad hoc mode. So if it is an access point mode means you need to define one access point and some nodes that can talk to the access point. So it is infrastructure mode, but we are going everything in a ad hoc Wi-Fi MAC. Okay. And establish this ad hoc Wi-Fi MAC into the net device. Now you can see the net device here. Net device in NS3. So we have channel, we have net device, we have node, net device container. Okay. So this is a net device, we install it. So we install Wi-Fi 5, Wi-Fi MAC and ad hoc nodes. So we install everything Wi-Fi MAC, and then this and this Wi-Fi PHY. Everything you install it on all the ad hoc nodes. Ad hoc nodes is totally how many nodes we have created? 50 nodes. That is 50 nodes we have created. For all the 50 nodes, we establish the ad hoc Wi-Fi MAC. Okay. So then mobility helper. Now how they are moving in a mobility fashion. So there we have using a position allocator called as a random rectangle position allocator. Okay. So that means I have a rectangular position. In the rectangular position, the nodes will move here and there slightly. They have a movement. So for that, I am using one rectangular position allocator. So x-axis here is 300. Y-axis is 1500. That means x and y is 300 cross 1500. The area, the work area. So that means all the nodes are positioned in 300 cross 1500. That means the x-axis is 300 and y-axis is 1500. So it is something like a rectangle. So the area is something like a rectangle. Maybe I'll just show you that. You can observe it. Just open the browser. Okay, whenever anything is asked like this, give 1, 2, 3, 4, 5, 6. Okay, so 300 cross 1500 rectangle. You can see it looks like this. 300 cross. This thing is yeah, it is something like this. 300 this side and 1500 this side. So that's what 300 cross 1500. So in this area only we are going to make the nodes to move. Okay, just to make it 300 cross 1500 work area. Okay, now for in this position, and here I have the node speed is, we have totally node speed is 20 and minimum is 0, maximum is 20. We have a varying speed. That's why we use a uniform random variable, because one node will move at 0.3, one node will move at 20, another node will move at 10.3, 4.5, 7.9. But I want to give a min and max. The minimum is 0.0 and the maximum is 20 meters per second. Similarly, constant node pass is 0 only. So that's what I am using. And mobility model is random waypoint mobility model. So randomly they will move within the position allocator. So if I use a position allocator, they cannot move beyond the position allocator, but they can move in a random way fashion. So within 300 cross 1500, I can move, but I cannot go beyond 1500 in y-axis, beyond 300 in x-axis. That is what here the mobility model will do. Okay. Now that is done. Now we are coming into the AODV helper. AODV helper, AODV, OLSR, OLSR, DSDV, DSDV, and DSR helper, DSR. We have the 4 protocols: AODV, OLSR, DSDV, DSR. Okay. Now IPv4 list routing, internet stack. Now I use a switch case. In C programming, we use switch case algorithm here. So here the M protocol, if it is 1 means OLSR, if it is 2 means AODV, if it is 3 means DSDV, if it is 4 means DSR. So we have these 4 protocols here. And if any other number is there, it is no such protocol, because we are configuring only for 4 protocols: OLSR, AODV, DSDV, and DSR. If M protocol less than 4, then we use this, and if it is equal to 4, we use this ad hoc nodes. Because DSR, dynamic source routing, has a different mechanism. That's why for that alone, we have internet or install. But for less than 4, we have a routing helper. Because DSR uses a caching, but other 3 protocols they don't use caching. That's why for caching we use this DSR main. Since they don't use these 4 protocols, they don't use caching, so we use the center routing helper. Okay. Now we give for address helper. So for the, what is the IP address we want to allocate? So set base 10.1.1.0 255 this, and we go for UDP socket factory, and on off we are using on off helper untime, constant random variable 1 and constant random variable 0. This is for UDP socket factory. This is what we are going to use. So number of sinks we already have 10. So as per the number of sinks, I am just sending the value start from 100 to 101. Okay, total time is 200 seconds. So this value is been printed over there, and that is a simulation. So finally it will be printing the throughput. So simulated destroy. After that we destroy the simulation and then we run it. So this is a simple example of AODV protocol. Okay. Now what do I do is, I have 2 variable here. The variable name is, I'll just make a note of it. So one is CSV file name, another is protocol. This is what I'm going to use. I'm going to use OLSR, AODV, DSDV, and DSR. Now I have another 25 minutes time remaining. In the 25 minutes, what do I do is, I will plot one variation between all these 4 protocols. Okay. So this is a manet-routing-compare which is there in the scratch folder. Okay, I'll just open the terminal. Okay, this is the terminal here. So to run any protocol, okay, now I'll just come back here. To run a .cc file in NS3, here is the command. Command is, again, I'll just run from the beginning here. Open a new terminal. cd ns hyphen all in one hyphen 3.38 slash ns hyphen 3.38. Okay. Now here is /ns3 space run scratch slash. Now in this case, manet manet-routing-compare.cc. Now this is the file we will be running. Okay. So cd ns all-in-one 3.38, ns 3.38. Now the command is to run is, this is the command to run. /ns3 run, and after that scratch manet-routing-compare.cc. Now this is the file we are going to use it now. This is what we are going to run. So before that, move the .cc file to scratch folder and open a new terminal. Okay, so we have already moved it. Now we are going for a, okay, now I am already in this folder now. /ns3 run scratch manet-routing-compare.cc. You can see this is the command to run. Okay, now first we will be run it. For you also, whenever you do this program also, it will be exactly the same way it will run. You can see here 100.2627 received one packet from this, 100.511 7 node number 7 received one packet from this IP. Like that, you can go up to because the total simulation time is 200 seconds. But only after 100 only the packet started receiving. So up to 100 seconds, the network is idle. It is not doing anything. Only after 100 it works. Okay. So you can customize this as per your need. Okay. So now this is what we got up to 199.762. It stopped. Okay. Now when you check ls, I have see that VIT Chennai.csv, VIT Chennai.mob, and this is where I have two files I got generated. Okay. Now I open both these files. So go to the terminal there, ns 3.38. Here I have VIT Chennai.csv. I just open here. Yeah, it's opening. It's getting opened. So what protocol we'll see it? You can see here simulation second 0, receive rate 0, packet received 0, number of things 10, AODB routing protocol. This is AODB. Transmission power is 7.5. Okay. Now see that up to 196, up till this we have this, but after 100 onwards, you can see the second parameter is receive rate and packet received. Okay. It changes. Up to 100, it is same. Because after 100 the simulation runs. Okay. So receive rate 10 AODB and this thing is same. Okay. You can see here. This is how the way the CSV file got generated. Okay. So this is on AODB. Now I want to run for DSTV and DSR also I want to run. Okay. This is only for AODB. Okay. Now I for that I'll do one small tweaking. Now let me use MOB also, MOB also. So this is a mobility position for each and every node. Okay, what time, what position the node moves. So this is the mobility. So totally 400 lines. Okay, so now what I do is, I'll just go to the source code here. So I have CSV file name, I have protocol. So 1 means OLSR, 2 means AODV, 3 means DSDV, 4 means DSR. Now this is very important. And the name also CSV capital letter, file F small letter, and name is N capital letter. Okay. Now I am just running the same simulation one more time. 4 times I want to run. So /ns3. Now this is what very important. Run. Then using double quotes, scratch, manet-routing-compare, space, double hyphen. Just come back to the source code. Copy this CSV file name. Copy. and already I have double slash here. I just pasted here. Anyway, I'll just run it over here. Just wait. So you can easily understand if I do that. Copy. To run the file for AODV, DSDV, OLSR and DSR, here is the steps. Okay. Okay. For AODV. Okay. So now what I do is, this is the command /ns3 run scratch manet. So CSV file name equal to, now I want to use AODV. So I want to create a file name called as AODV.csv space. Then again I go back here, protocol. Okay, I just copy this. One is OLSR, two is AODV. Okay, now two I want to compare. Okay, now double hyphen protocol equal to 2. 2 is for AODV. Okay, now close it. Now copy this. See the command name. So the command line argument is, without recompiling, I am just creating the file name as aodv.csv and protocol is 2. That means it is for AODV, right? Anyway, I'll just run it. I click paste. Now this is for AODV. But we have to wait up to 200 because I have only 2 GB RAM. I have just fixed. So we have to wait up to 200. Anyway, I'll just plot also. Let's see how do we plot it. That's what very beauty of this. We'll plot the receive rate for all the 4 protocols. Okay. Yes, it is ending now. Done. Okay, now we can see we have one aodv.csv. Can you see this file? aodv.csv. Okay, so keep it like this. Now one more time I need to do, for what we have to do is for OLSR. For OLSR, the same command. Here instead of AODV file, I want to create as OLSR.csv. Protocol is, now this is where we have protocol is 1. So this number I want to make it as 1. 1. Okay, so now I compare this file, Control C. Then I come back here, clear, right click, paste. Now see OLSR.csv, protocol is 1. Now when I run it, yes, this is for OLSR. Yes. See that I have another file aodv.csv. I have OLSR.csv. Can you see? 2 files got generated. AODV and AODV already created first time. OLSR second time. Now again I come back here. Now these 3 for DSDV, 4 for DSR. Okay. So now the same program, what I do is, for DSDV, what I do is, it is 3 na. So the protocol name is 3 and here the file name is DSDV. Similarly, for DSR, protocol is 4. But usually DSR sometimes misbehaves, but let's see. Okay, so DSDV and clear the screen and right click, paste. Now this is what DSDV. Nodes, and what is the difference between nodes and sync means? Nodes means the number of nodes participate in the simulation. Sync means number of destination nodes. I want to make which are the nodes who receive the packets only. So that is sync. Source to destination, that's what we are telling now. Source to sink. Sink means the receiving nodes. Out of 50 nodes, only 10 nodes receive the packets. Okay, that's what means. Okay, so now we can see this is for OLSR one file, AODB another file, DSDB also got created. Now finally we have this thing, DSR. Control C. Clear the screen. Okay. Okay, this is DSR. I think DSR takes a little bit time. Okay, at the end, there is some obsolete thing fallback. Anyway, no issues. DSR usually do that. Okay, now you can see we have aodb.csv, dsr.csv, dsr.csv, and olsr.csv. Okay, so now let me open all these files from this src. From here, olsr, open with Notepad. Okay, I'm just opening this file. Okay, so this is the file. I'm just opening it here. This is for AODB. Similarly, I can open all the other files, DSDB, DSR, and OLSR. All the CSV files I am just opening. Okay. So this is for DSDB, and this is for DSR. Okay, and finally this is for OLSR. You can see automatically the name of the protocol is here OLSR. The name is DSR. The name is DSDB, and the name is AODB. Okay. Now second parameter is receive rate, and third parameter is packet received. Okay, so we have a variation in second and the third parameter. So second is this parameter and third is this parameter, 33, like this, the number of packets received. Right. Now I go, since 4 values are there, I want to have a comparison between all the 4, AODB, DSDB, DSR, and OLSR. So if you know any comparison methods, you can try. How we can try is, wait, 199. Okay, this thing is, okay, one method is you can able to try Excel sheet. You can use Excel sheet and then you do the plotting. But I have NS3 has one GNUplot as one software. So I can write a small source code for handling this thing. So maybe it is easy for you. I'll just show you that. Set terminal PDF. I'm going to print everything in PDF. Okay. So I mean AODB and protocol dot plot. The name of the file is plot plot. That's what I am going to save it. Protocol dot plot. Okay. Then set output. The name of the file is protocol compare.pdf. I can say the name of the file as compare.pdf. Okay, so set x label. So x-axis is time in seconds. Set y label. Y-axis is receive rate, and packet received. There are 2 things here. Packets received. Okay, so then plot. So I need to plot what are the parameters here is plot. First thing is aodv.csv. This plot aodv.csv. Which parameter is the first line you delete it because first line is a text line. So we'll have okay, delete that first line, save it, and comma also you remove it because comma is also not command control H. Comma will be removed, and instead of comma, you'll have a blank space. Replace all. You can see everything removed. Okay. So similarly for DSTV, control H, replace all. Similarly this control H, replace all. Similarly this control H, replace all. First line alone I delete. The first line is a text line which I am going to process it. So how the method is easy. Okay, now first parameter is that is the x-axis. Second is the y-axis, and third is also y-axis. First, second, and third. I am going to use the first column, second column, and the third column in all the 4 files. Because all the 4 files resemble the same thing. Only thing is the protocol is different. Okay, now what I do is plot aodv csv using 1:2. 1:2 means first column is x-axis and second column is y. It is like x:(y). That's what first column will be x-axis, second column is y-axis with points. With only points. Title is aodv, comma. I use the same thing now. Copy here. One more time. One more time. One more time. So second time is 1:3 only, but instead of this now OLSR. OLSR. The title is also OLSR. Then here it is DSR. The title also DSR. So when this is DSTV. DSTV. Last comma I delete it. Okay. So this is first thing. It is receive rate. Okay. Now I will use this thing here. And same thing here. X label, Y label. Now I copy this again one more time. Second graph. Y label is now packet received. Okay. So instead of 1:2 now 1:3 because third column is a packet received. So but all other thing remains same. Okay. So I have 2 graphs will be ready. So Y label, X label is common, time is seconds, Y label is receive rate, and here is also. Maybe if you want, you can use this also. Control C. Control. Okay. Now maybe here you can use set title. Set title as receive rate and packet received. Title of the graph. Okay. Now this is my code of GNUplot. So very easy. Set terminal PDF. I am going to use the terminal as PDF. The output of the file is compare.pdf. The title is this. X label. What is the x-axis? What is the y-axis? And plot is the command. That's all. Okay. Now I will be running this example. So GNUplot protocol.plot. Yes. No errors. Now I go back here. Here you can see compare.pdf. Now I got 2 graphs you can see here. AODV plus OLSR is this, and DSR is this, and DSTV is this. This is for receive rate and packet received title. And here it is packet received in the y-axis and x-axis time in seconds. Only after 100 only the simulation starts. Otherwise it isn't. But it is only points. I have given points now. That's why this error. Now what I do is I'll go back here. Instead of points, I'll say lines. Lines. Instead of points, I'll say lines. Okay, control H. Instead of points, I'll say lines. Okay. Now I will run it again. Now you can see. Now this is the graph for receive rate and packet received. So this is 1:2, and okay, this is how the way up to 100 nothing happens, because up to 100 there was no simulation. Only after 100 to 200 the simulation runs here. So AODV is a pink color, OLSR in green, and DSR in blue, and DSTV in this. So when you see that the maximum is AODV only. The receive rate is very high in AODV. You can see the maroon color. So if you want to increase the graph size, so if you want to increase title AODV, after that if you use line width 3, then everywhere you can use a line width 3. You do like this. Now again I run it. You can see this line width. You can see how the graph line width increases. So second thing I didn't do, but only with the first thing it is increasing. So now in this case, by seeing the graph itself, we can directly see that AODV have a better receive rate compared to the other thing. So in the y-axis, you can see the maximum thing, the DSR clocks is 24. At one point of time, it was at 160. It has 120, 24 obviously. But many times you can see around 20 AODV clock 2 times, and around 16, 17 AODV clock multiple times. And but among the lowest performing is I think DSDV protocol. So DSDV is the lowest receiving rate, whereas AODV had the highest. Similarly, packet received also same thing, but packet received you can see it is 50. The y-axis the maximum is 50 here, and up to 35 to 40 that AODV and have received it. On an average, AODV did well, and that's what DSDV performed less compared to the other protocols. So this is the way we can able to generate graphs in the receive rate. Okay, so actually this is one project done by your PG students as performance comparison of wireless ad hoc routing protocols. But using this one file, you can able to do many results you can able to do. Okay, so now what I do is now in this case, what they said is 7.5 dBm. I will go with some higher dBm. dBm I will make with the higher milliseconds. dB, so instead of 7.5, I make it something, but again I need to run for 4 times. Okay, so what do I do is I'll just close these files. Okay, in this close this file, so control F 7.5, I'll just check it 7.5. Oh, here transmission power is 7.5. So what do I do is I'll change it to 9.5. I'll just increase that to 9.5. Okay, same 50 nodes here. So I'm not altering 50 nodes. So you can alter anything as per your wish. So you can do that. Okay, now what I do is again I go back here. I just run all the files again one more time. So first control C. Now my aodv.cc file also will change, because now this is for new, dBm. Earlier it was 1.5, now it is 9.5. I can able to compare the old with the new also, that can able to compare. So this way I can able to do multiple results. Okay. So the time is 12 now. Maybe another 5-10 minutes I'll just take. Okay, this is AODV. Now next thing also I'll just say. Now that receive rate I will compare with the new receive rate. Okay, so for dBm, is there any variety? Is there any change in the dBm that will compare? But 200 is the highest point there. 200 seconds. That's why you have to wait for some time. Anyway, some questions. Okay, it is done. Now next thing is OLSR. Next thing is DSDV. Okay. Next thing is DSDV, and finally we have DSR. So if you have any queries, you please let me know in the chat box so that I can, or else I will give an example. You can try the same example exercise for you. Okay, now you can see this is an exercise. Okay, now this is done. In the meantime, I will just run this. I will just explain you how that can be done. This is DSR. Okay. Now the exercise is in the manet-routing-compare.cc file. In the same file what I worked now, plot the characteristics of AOD and OLSR alone. I have not used other two protocols for the average receive rate when the number of nodes are 30, 50, 80, and 100. So that means now the number of nodes is by default 50. Now what you do is you just change it to 30, then one more time change it to 80, and one more time change it to 100. For that, take the running for AODV and DS OLSR for both the times. And then average receive rate means you compute the average value from the Excel sheet. From the CSV file, compute the average receive rate. Then plot for 30 in the x-axis, 50, 80, and 100. What is the average receive rate for the number of nodes? You have to have two graphs. One is for AODV, another for OLSR. Now this is an exercise. It very easily can be done. Okay, now still it is done. I will just show you another receiver. I already have that graph. This graph I keep it ready, and I'll plot one more thing also. Okay, now this thing I just keep it ready like this. Yeah, it is done. Okay, fine. So now Control O. I'll just open all the four files: AODV, DSEV, DSR, and OLSR. All the four. First parameter I did delete. Control S, Control H, comma, blank space, replace all. Save. Replace all. Control S, Control H, replace all. Control S. Control H, replace all, save. Okay, so now again what I do is I'll open the protocol file, Control O, then protocol.plt, the plot file. Here compare means here it is compare to. I create one more file with the same data. So because everything is same only. Now let me run a GNUplot. Yes. Now it will create one more compare over to file. Now can you see here? Can you see here? Okay. So you can see now, this is the left hand side is compared to is now recently what we have done. So we have increased the decibel, the transmission power to 7.5 to 9.5 dBm. For that, how the received and packet received are affected. And the right hand side, we have the decibel rate is dBm is 7.5. So for the 7.5 dBm, you can see how the performance in the initial time, you can see the blue color, see it is DSR. In the initial time, see up to 100, immediately it clocks 20 receive rate. But here it goes up to 160. So because of the highest transmission power, it instantiates very high in the peak. So most of them are in the peak. You can see the AODV also how many times it clock its peak, and even you can see the orange color DSDV also it has clocking somewhere around 14 in the compared to. In the compared one it was nominal. So increase in dBm will increase the transmission power. So if you compute energy, then obviously you can compute the energy occupation will be more when the dBm is more. If it is less, when the dBm is less. So this way you can compare two graphs with receive rate and packet received. I have just done only packet receive rate, but we can able to compare throughput, flow, energy, everything we can able to do on this comparison. Okay. So this way we can able to compare our research, our manet routing protocol, our wireless communication protocol with the available results here. So I have not gone anywhere. The file is already there in NS3. Only thing is we need to use the file and make it to our discretion, and then we have to change it as per our convenience. Then we analyze it. So this is our second step. First step is to understand the code that we already done. Second step is run the code with the various parameters. That also we have done it. Third work is we can do some small experiments or something. So that I have given you. Fourth one is we can modify something. Okay, oh this part is lagging here. Let me modify this protocol. That is for the fourth step. That's where we call that as a research. But till this time we can able to do everything as per our convenience.
So thanks for watching the video. So please subscribe to my channel and please forward this video to your friends and scholars and students. Thank you very much.